Good night, everyone. In the course MST 2022, apply statistical methods. Yours truly, Darius Sugar, will be presenting on two-sample Mann U test. What's the outline? We have 1, information about the test. 2, test type and variable type. 3, assumptions. 4, ranking data for this type of test. 5, testing assumptions. 6, steps in hypothesis testing. 7 and 8, we're going to work 2 examples. And 9, we're going to do the R implementation. Information about the Wilcoxon rank sum test. We have the Wilcoxon rank sum test, or the Mann U test. It's a non-parametric test that can be used in place of an unpaired t-test. It is used to test the null hypothesis that 2 samples come from the same population, that is, they have the same median, or alternatively, whether observations in a one sample tend to be larger than observations in the other. Although it is a non-parametric test, it does not assume that the 2 distributions are similar in shape. In the Mann U test, the data from both groups are combined and ranked from lowest to highest. The ranks of the observations are then summed for each group, and the U statistics is calculated based on the difference in rank sums between the groups. It is one of the best known non-parametric significant tests, and it is more powerful than the Wilcoxon sign rank test. This test statistic is typically denoted as U. So once you see U, you will see the Mann U test. 1, test type. You look at the test type and the variable type, which is a non-parametric. 2, the variable type. 1 variable, at least ordinal in nature. Here I have a diagram showing the levels of measurement. You have the nominal, the ordinal, interval, and the ratio. And we know for this statistic, the nominal is not applicable. 3 assumptions for the test. 1, the sample must be a simple random sample, and the 2 samples should be independent. The groups should have similar distributions in shape for meaningful comparisons of medians. 4, ranking data for this type of test, which is the Mann test. To rank the data for these tests, we have to follow these general steps. 1, you need to combine the data. If you're comparing multiple groups, combine all the data points into a single list. 2, assign ranks. Assign a rank to each data point based on its relative position in the combined list. The smallest value gets rank 1, the second smallest gets rank 2, and so on. 3, handle ties. If they are ties, assign the average rank to each tied data point. For example, if 2 data points are tied for the 3rd and 4th positions, assign them a rank of 3.5. B, when ranking 3 items that are tied, you assign them the average of their ranks. C, for example, if you have 3 items that would normally rank 4th, 5th, and 6th, you would assign them all a rank of 5. Why is this so? Because we take the average, 4, 5, and 6, and we divide them by 3 because we have 3 numbers there, and that will give us 5. So they will have a rank of 5. D, this method ensures that the total sum of the ranks remains the same, even when they are ties. Once you have got the data rank, you can apply the Mann U test to determine if there is a statistically significant difference between the groups. 1, simple random test. assuming the data provided is from a random sample, the groups should have similar distribution in shape for meaningful comparisons of medians. The Wilcoxon rank sum test checks if the medians of the two independent groups are different. For the test to be interpreted accurately, it's best if the distribution of the two groups have similar shapes. If the shapes are drastically different, a significant result might reflect a shape difference rather than a median difference. The groups should have similar distribution in shape for meaningful comparisons of medians. Using box plot to better understand if the box plots look reasonable, similar in shape, that is symmetrical, whisker length box size, you have visual evidence supporting the assumption of similar distribution shapes. As you can see in the diagram here, if you look at this box plot for large sample size, something you check, look there, the median here, they are very similar in shape. You look here, you can make comparisons there. But as you can see here, interpretation from this box plot, the median or central line inside the box is slightly higher than in group 2 than in group 1, however, still generally identical. We have the interquartile ranges are very similar, indicating a comparable spread in both groups. The whiskers extend similarly, meaning the range of values is comparable. As you can see, there are no extreme outliers, which supports the assumption of similar distribution shapes. Since the distribution shapes are similar, the Mann U test is valid for this data.